Hello, everyone. Welcome. Hello, everyone who's joining. We have just started the webinar. Just going to give a few minutes to let people log in to this Zoom link. Welcome, everyone. I'm looking on the controls in Zoom here, and I can see who are some of the attendees. Some familiar names, which is great. Welcome. How about we give it just another 30 seconds to a minute, and then we'll get rolling. Hello, everyone who's joining. We're just allowing people to settle in to join the link. Okay, well, why don't we get started? Good afternoon, everyone. Welcome to What's Your Data Path, a series of webinars that we are holding with data scientists to learn more about careers in data science. My name is Jo Louie, and I work at the nonprofit organization Education Development Center, or EDC, based outside of Boston, Massachusetts. I am the director of Data Paths, which is a multi-year project funded by the state of Massachusetts to promote interests and skills in data science among students in grades K through 16 throughout the state. Next slide, please. So the Data Paths project consists of a team of people who are providing an array of professional development learning opportunities and curriculum materials for teachers to integrate more data science practices into their current teaching. We're also developing an online career hub, including a suite of resources to help students learn about data science careers. This webinar is one in a series that we'll be holding over the next year and a half to talk with professionals working in a wide range of fields and who use data intensively in their work. For those of you attending live, our goal is to inform and potentially inspire you to share information from today with young people who may be interested in pursuing data analysis careers. We're also recording this session and aim to place on our project website the whole hour-long webinar or clips that people can view again or share with other students or learners in classrooms or in out-of-school settings. Next slide, please. So here's our agenda for the next hour. We'll have two guest speakers present about themselves and their work, each for 10 minutes. The first speaker, Sydney Batchelder, is an Information Systems Associate at the Woods Hole Oceanographic Institution out on Cape Cod. The other speaker, Emily Wojtek, is a data scientist at MIT. After they speak, I'll jump back in to have a brief discussion with the presenters, and then we'll open up the webinar to take your questions. Just to note, all participants are muted during this webinar, but you can pose your questions in the Q&A box anytime during this session. Now, before we turn to our speakers, I want to acknowledge Jen Stiles, who is a member of the Data Paths team, who is working the slides and technology aspects of this webinar behind the scenes. She and another member of the Data Paths team, Johanna Nicola, will also be helping to monitor your questions as they come in, so we can read them to the speakers at the end. So we're on to the next slide. Let's turn to our first speaker, who will be Sydney Batchelder. So please take it away.
Thank you. Hi, I'm Sydney Batchelder, and the way I usually introduce myself and my job to people is I write software for marine scientists. Slide, please. Um, I am 34 years old. I got a Bachelor of Science from Worcester Polytech. I live with these wonderful creatures that you can see on your screen right now. I like science fiction books. I have ADHD. I'm part of the LGBTQ community, and I work for the Woods Hole Oceanographic Institute. Next slide. For those who haven't heard about it, it is an oceanographic research institute on Cape Cod. You might know them best from their help in finding the Titanic wreck using their ROVs. I've been with them for 10 years. I started working with them part-time as a robot fleet manager, so I pilot them around in the oceans. But more recently, I've been part of their IT department as an application developer, which means I get to interface with a bunch of scientists and help them achieve all of their like data dreams. And I'm an enabler, if you will. Most of my time nowadays is remote, so I'm working from home right now. But I sometimes get the opportunity to go out to sea. Slide, please. So, uh, I've because of the nature of my work, I've touched a bunch of different projects. There's a weather station and observatory on Martha's Vineyard, and I'm in charge of making sure that data gets logged properly and gets pushed to the website properly. I've made visualizations for climate models, which you can see in that top right photo. I've made applications to send out alerts for harmful algal blooms to save that go out to oyster farmers. But the majority of my work is in AI and machine learning with imagery. So that's plankton imagery, that's fish teeth, that's migrating herring. And on our next slide, we're going to just see what a bunch of my data looks like. So this is what I look at on a daily basis. The top left two images are plankton. They come from an ImageFlow Cytobot. And this is constantly taking pictures of plankton, forever. And the other photos you see here are fossilized fish teeth from a different project. And although we have human labelers who are very specialized and can name all of these things, they can't keep up with the huge influx of data that we have. So typically my job is to get a computer to do the image recognition to label these things for us. But that by itself isn't terribly useful. You need to be able to do something with this data now that it's all labeled. And that's why on our next slide, I'm emphasizing that the data that we have has to tell a story. So here we're looking at collective readings for salps. Salps are gelatinous creatures. Um, and this imagery is taken with something called a Stingray Shadowgraph sled. It's that little device. It gets pulled behind a ship and it goes up and down the water column, taking pictures of everything that's in it. Um, the top image where there's all those little W's, that is color coded to show where these things are found through time through a water column. But that's kind of difficult to like get any sense from. So if we look at the bottom left image, we can see that that blue line indicates where we are seeing most of those creatures. And we see that there's a large spike at the top at 0 meters of depth, so at the surface, and in the middle at 500 meters of depth. But we can go a little further. And so if we break down this data into day and night cycles, we can see that this creature, this salp, migrates from a surface layer during the day to a middle of the water column layer at the other part of the day. And so with this, we can start telling stories and understanding about the creatures in the ocean. Um, but all of that has to do with how we pull apart data and look into those details. And my job is to enable the scientists to be able to tell these stories with this data. Next slide, please. So, how did I get here? Well, I've always loved the ocean. So when it came to studying things, but I also like making things, like understanding how the world works. So I went to school for engineering, but I kept my uh, like the topics that I was interested fairly broad. So a little bit of mechanical engineering, a little bit of electrical engineering, a little bit of computer engineering or computer science, robotics, which is a mix of all of those things. But whenever I had an opportunity to self-direct a project, I'd always try to bring it back to something that was more ocean focused. Um, and uh, although my very first job out of college didn't really have anything to do with the ocean, as soon as I got an opportunity to get a foot in the door at a place like Woods Hole, I took it, even though it was part-time work, even though it was probably a little bit of a pay cut. But once I got there, I was proactive in being involved with the people there. So I didn't just do that robot fleet management thing. I also made software and tools to read the data from those gliders, to better visualize things. I got involved with other projects, sort of like as opportunities show up, and I got recognized for it, and they eventually gave me a full-time position. And that's how I got to be able to be involved in so many cool projects, all of which involve data all of the time. And uh, I love what I do. And it's a pleasure that I get to be able to share that with everybody here. Thank you. That's it for my presentation.
Great. Thank you so much, Sydney. That was great. Let's now switch to Emily. Emily Wojtek.
So hi, my name is Emily Wojtek. I am a data scientist. And I'd be lying if I didn't say I've always been a little bit of a nerd, been a scientist at heart. This is a picture from back in the day, but even then I was collecting data and making images and, again, trying to tell the story that Sydney was talking about. I currently work as a data scientist at MIT, but I am not on the research side of things, which is often what people think about when they think about MIT, excuse me, is people doing research. Instead, I work on the operations side of things, and I'll talk a little bit more about that. But my path here has not been a straight one, and that's part of the reason that it's been really enjoyable, and I think is a really important part of a data career, is that it can take a lot of different paths, and there are a lot of different ways to get into data. So we'll go to the next slide. If I think about what I do all day right now, as I told you, I work at MIT, where people are learning, inventing, and solving big problems in science and technology. There are over 2,000 students, both undergraduate and graduate students, as well as 12,000 employees. And my job is to think about those employees. I use a lot of data to try and help figure out, what helps people enjoy their jobs, what helps people do their jobs effectively, how we can, encourage people to stay longer, all sorts of things like that. So I work with a lot of survey data at this point, where we ask people a couple times a year how they feel about what they're doing, what excites them, or what do they want to change about working here at MIT. But as I've said, it's not been a straight path. I've not always been in the HR space. I actually used to be much more of a earth scientist, which we'll get into on the next slide. So I actually started my career as a geologist. There are a lot of different pictures here. I really love geology because it got me outside. And really, much like the Sydney showed, I got to explore the world and I got to ask a lot of really interesting questions about what was happening. And on that path, you can see here, I started out using some hand samples, using my geologic hammer, collecting some samples on a boat. But eventually I became more and more into the data side of things. And in that final picture, it's a little bit hard to see, but I'm carrying this piece of equipment. It looks kind of like a big shoebox. But that's one of the tools that we used to try and figure out what was happening below the surface. And so I got really excited about that. We'd collect a lot of data. We can go to the next slide. So we'd go out into the field on a boat here in some cases, or out just, hike out to where we needed to be. And we'd spend a couple of days collecting data in the field using a lot of different equipment. But then we'd get back to our offices and we'd spend many, many months working on the computer to try and make all of these individual data pieces into that story that was really going to answer those questions that we were trying to get at. And this was, a lot of fun. I was able to visit a lot of really cool places. But slowly I started to realize that I was becoming more and more interested in the data side of things, and the computer and the programming, and how I could get the machines to do what I wanted. So next slide. So here are some examples of that data that we collected. Again, or you can see we're sort of on that boat along the top surface there on the left-hand side. And we are using equipment that allows us to see into the subsurface and starting to tell the story of what happened. So this is an example from Lake Superior. It's an area where the glaciers moved through, they cleaned everything out, and then after the glaciers receded, we started having lots of layers of sediment deposited. And so we were trying to piece together the history of kind of what happened through time. On the other side, it's some other data. It's a little bit different type, but it's allowing us, again, to look at what's happening in the ground. And in this case, we're looking at differences between years. And so you might notice between the top image and the bottom, we no longer have that yellow area, or it's not as bright in the second one. And that's actually an area of ice that was melting away between those 2 years. In this case, just in the ground, not on the lake as we were here. But as I was saying, I began to realize I was getting more and more excited about the data. And so really started to turn my interest towards that. And that's when I started to make this transition into the current role that I have. Next slide. Yep. The only problem was I was having much more fun writing code and working on that data than answering those specific earth science questions. This may look like gobbledygook to all of you, but these were the sorts of things that I began to realize I got most excited by, sort of thinking about these flow diagrams, where we were pulling different things from, how we could put them all together into the computer at one time to really figure out what was going on. And how I could make this gobbledygook on the left-hand side into something workable, something that other folks could use. And so I started writing software for other scientists to not have to do all of this thinking that was on the left-hand side, and really just be able to drop their data in and figure out what was going on. Next slide. And so that's really when I decided to make this change, and I decided to start working in data science. It was a lot of what I was doing already. Used a lot of the same skills that I had developed as an earth scientist or as a geologist. So skills about asking good questions, taking good notes, trying to figure out, work through a lot of data. I did have to work on improving my coding. I could do some, but I spent some time. I took some additional classes to try and get better at the coding side of things. And then I ended up in this role as a data scientist in human resources. And people often think that's a little bit strange as a trajectory for a scientist, but I actually really enjoy the role that I'm in because I'm at MIT, an organization where there are a lot of scientists and a lot of really smart people. I get to be a little bit of a go-between between the organizational side of things, the folks who are, deciding, where we work, how we work, those sorts of things, and the scientists themselves. So I've now been doing this for about 5 years, and just recently I became a team lead. So now I don't just think about myself, but I have a team of 3 or 4 other business analysts who work for me. And I get to sort of drive the projects that we work on. Right now, we're doing a lot of work to help with data visualization. So a lot of building out of dashboards so that some of um, the leaders of the organization can make better decisions about how they run the organization based on how people are feeling. Really some data-driven decisions allowing us not just to think about, in our gut what sounds like the right choice, but actually using data to support that. So that's how I've ended up where I am. I don't have quite as many pretty pictures in my current job. I spend a lot of time sitting in front of a computer and not as much time out on a boat or in the field. But I still really enjoy what I do. It's, a lot of storytelling and helping connect the dots. And I get a lot of joy out of that. Problem solving, all that good stuff. I think that's all I've got.
Great. Thank you so much, Emily and Sydney. That was awesome. Thank you so much for sharing. So now I have the privileged position. I get to ask lots of questions, which is one of my favorite activities, is to ask people questions. So I'll hog up the question asking first, and then we'll move it to a broader Q&A session. So if folks have questions as we're talking, please put them into the chat, and then we will get to them. So let me start with Sydney, since you went first. You talked a little bit about how you ended up working at Hui. It sounds like partly because you love the ocean, and it sounds like you were gravitating towards jobs that could allow you to be in the ocean, be by the ocean, learn, explore the ocean. I'm assuming that's correct. Now I'm wondering.
Yeah, that's
Yeah,
right.
go ahead.
Um, whenever I had the opportunity to direct the theme on a project or anything like that, I would try and make it ocean themed. And so I think that showed up on like resumes when it came to applying to projects and things like that.
Mm-hmm. So would it be fair to say that you ended up working in data not so much because you love data, but because you love the ocean and because the work that they were doing involved data, or you did love data, or how did that come about?
Ah, um, I'd say that the reason that that I did well in the opportunities that were presented to me, sort of like these data opportunities, I'd say that's because uh, I treat working with data kind of like a puzzle and working with code kind of like a puzzle. And I'm a very puzzle-oriented person. Like I love board games, for instance. I like finding the right or the best way to do something. And so I had a little bit of experience writing code and working with data from university, but it was only when I got to get like my hands dirty and had the opportunity to like try things that I really was able to dig into, well, how do I make a database? What is the best way to represent this data? How do I best plot this set of things along these kinds of axes and try and get the point across of what I'm discovering? And so I came to having a love for data because of the challenges and because of the puzzle of how to best work with it, best present it, best transform it, etc.
Mm-hmm. Mm-hmm.
Mm.
And presumably, I don't know, at Hui, there are people, does everybody work with data? Or is that something that there's a huge need for it because there's a lot of data and then you fell into it? Or
I think I think there's so much of it that there's always going to be an opportunity to better present it or better show it or and stuff like that. We collect a lot of data nowadays, but not all of it gets shown or interpreted necessarily because there's so much of it. And there are public data sets, which I'm sure have a treasure trove of insight that could be gleaned from them, but that, just takes the right kind of person to care to take a look at it.
Mm-hmm. And when you say there's so much data being collected, are people collecting this data just because we can, or are they being driven by specific questions to
In
gather that
some
data?
It's a bit of both. So at Hui, most of the data that gets collected or that gets used um, are are used for a particular research interest. But that data set is still public, and there's still additional information that can be taken from it. So, for instance, when a ship goes out on a cruise, you might have uh, data that comes from that Stingray sled, for instance, but the ship will also have sonar and scanners similar to what Emily's presentation had. And it might have, sensors on the surface, to gather wind, and that might be associated with something that's not part of the cruise, like sea surface temperature, which comes from satellites. And the way that you pull in like data from these different places can grant different kinds of insight. So some of the data that we have, yes, is sought out to answer specific questions, but so long as that data is made available to a more broadly, then other people can come along and say, I have this other question, and maybe this can help me tell that story for this question that I'm looking for.
Mhm. Okay. And then what data skills did you have or did you need when you first started? And then what types of data skills do you need now to do? Or is it all the
Sure.
same?
Oh no, it's certainly evolved. Um, the data skills that I needed early on were uh, not rudimentary because you can still do so much with it, but we're closer to just like a single thing. So I have some data that's coming in. It's got position, it's got a few instruments, and I can put it all in a CSV, and I can use something like Pandas to open it up and make plots. Nowadays, a lot of my the sort of skills that I need is also well, the CSV is going to be not sufficient for everything that I need to do. I need something larger. I have data sets that don't all fit in a single table kind of schema. And so I start thinking about, well, does this need a database? What kind of database does it need? How do I make associations between these different parts of data? And how do I get all those different data sets, which are collected in different ways and have different names for things, to work together? And so that's the challenge nowadays, how to make it how now that I have how do I access so much more of it? How do I work with more of it? And what's the best way to make it accessible, not just to my project, but to other people in the science community?
Got it. And of all that work that you're doing now, what aspects of working with data are most interesting or motivating to you, would you say?
Mm, okay, it's a little silly. There's two parts to it. One is number go up, that feeling when when you're playing a video game or a board game or working with machine learning algorithms is they create scores. They tell you how well they're doing oftentimes, and adjusting your software to improve that number. The scientists I work with love that, and it feels good. Number go up. But also, um, I'd say it's being able to help people. I've had scientists come in and say, I have this data set, but I'm having a terrible time like getting through it because I got these pictures and I got all these different fields and I can't search on both of these at the same time. It's cumbersome. And now I might come in and say, I have this software solution for you. There's this thing that can do both of those things. Let me make a server for you. Let me host that software for you. Let me upload all of your data. And now you can view and parse and download like never before. And whenever I do that for a scientist, their eyes light up and they're like, I've been doing it the hard way for like 10 years. This is revolutionary. And I'm like, you're welcome. It's my pleasure. This is what I love to do. I like enabling the scientists to be able to do their work better. That's really satisfying.
Well, great. Well, thank you. So
Thank you.
now if I can turn some questions to Emily after peppering Sydney for a few minutes here. So Emily, it sounds like you started out as a geologist and we're using a lot of data to answer geological questions about the Earth and why it looks the way it does, I guess, and why it behaves the way it does. But then you said that you turned to focus on data science in part because you loved coding. So can you say more about the coding piece? And this sounds like it's also a question that has come in through the chat. Like, what do
Yeah,
you
I
mean
saw
by,
that.
yeah, what do you mean by coding and what do you love about it? And say more.
So there are a couple of different pieces. But I think for me, what I started to realize, when I started as a scientist, I sort of took everything. I guess I realized that tools did things for me, but I didn't realize how much control that I could have in, what exactly they do for me. And as I got a little bit deeper into the data and, sometimes even into the tools themselves that we were using to, say, measure electrical signals. So we measure voltages. But you start to realize, this instrument is measuring electrical signals every 10 seconds because somebody told it to measure every 10 seconds. And you start to realize, well, I could actually tell it I want it to measure every second. Or, you start to realize, I did at least, the power of code, the fact that everything around us is coded. And somebody's made a decision, even, the buttons on our screen now, like somebody's made a decision that this is going to be located here. And when you push this button, it's going to do this other thing. And I guess it was sort of that feeling of power in some ways that I liked about coding, that like I had a little bit of control. But when it comes to thinking about coding, I think that there's two really important pieces, and sometimes they get confused. Sometimes we don't think about them as two different things. There is the language of the code itself. So there are a lot of different options out there. I first learned in a language called MATLAB, which is kind of a language that's used more in the academic space. But now I use a lot more Python and R, which are other languages. And much like learning a foreign language, you learn how to speak it. You learn how to tell the computer what you want using this particular language. I think what's a really important piece to understand is you can only tell the computer what to do if you really understand what you want it to do. So there's sort of the pre-piece, the piece before actually writing the code, where you need to be able to, think about and sort of parse into pieces what you want to happen. And those two are really different pieces. And sometimes people get them confused and say, I can't do all of this because I don't know all these different pieces. But again, I enjoy the act of, okay, I have this file and now, I want it to do this, and then I want it to do this, and then I want it to do this, and then going to write the code. And when you break things out into much smaller pieces, it becomes much easier to do. And so that's what I started to do when I mentioned, I improved my coding. Well, I knew how to do exactly, I had been using other people's code, I was running it, and I understood what it was doing, but I wasn't writing my own. And so then I started to expand using a lot of online resources, really, watching some videos, taking some free online classes to get a little bit better at it. Like, why are we actually writing it in this way? Or is there a better way to do that? But always coming back to the why. And I think that that's a really important piece. And so, you know, for me, it's always important to be able to explain in English or in a sort of verbal language what I want to do before I try and put it into code. And so you were talking about sort of what are important skills. And I think that communication is a really, really important piece to the data story. Everybody wants to jump in and learn how to code. But if you can't identify, what you want to happen first, then the coding is even more challenging.
So speaking of languages, there's speaking in normal everyday talk, and then there's the computer languages that we program in to talk with the computer and to make it do the things we want it to do, right? Do you just work with, like, how many different languages did you have to learn? What did you learn when you started? What do you use now? And
Yeah.
yeah.
I use a whole lot of different ones now, and I don't want to scare anyone off by, saying it might be close to 5 or 6. But they come much easier. Like each consecutive one comes easier than the first, because again, it's about sort of building the building blocks. And again, once you know what you want it to do, then it's just like figuring out exactly how do I phrase this sentence, for example. But I primarily use Python at this point, which is, I think, a pretty common one in the data space. Because I work with a little bit more social science data now too, with the surveys that I do, that community tends to use more R. And so, I've picked that up so that I can look at resources that other people have built. Because that's the other part about sort of the data world and coding. You're rarely doing everything by yourself. You really, things would go really slowly if we all build everything from scratch. And so, there's a lot of sharing of code and different things that goes on. And so being able to sort of understand some different languages can help make that easier to share amongst people.
When I hear people talking about coding and computer programming, I think of computer science. You call yourself a data scientist.
Oh, yes.
Why do you not call yourself a computer scientist and a data scientist? What's the difference? How would you discuss those two?
This is a good question and a topic of lots of conversation. I think for me, one of the reasons that I use the term data scientist, among others, one of the things that I think that I bring in my particular role comes back to some of the things we've already talked about, but it includes the ability to communicate very effectively, the work that we're doing with the data. And not to diminish other roles like computer science and things, but I think that sometimes those roles are lean a little bit more technical, and spending all of your time writing the code, making this code connect to that code. And though that's a part of my job I really enjoy, I actually spend a lot of my job having conversations about data. And I think that for me is a little bit more the data science piece of it, is connecting to the larger picture. So I work with people data. I work in human resources. And so there are a lot of questions and conversations about how do we generate data and what is correct use of this particular data. And so those are a lot of the conversations that I have. I personally like to say Fridays for actually writing code, because that is my favorite part of my job. But if I'm honest, I don't actually get to write code every day, or even every week sometimes at this point. I now have a team. They do a lot of the code writing for me. And I lean a little bit more into the interpretation of the data. And okay, we've done this. What does it mean for running the business? What does this mean for the decision makers? So that's a little bit of the transition that's happened in my career. And it's both exciting because it means that I'm able to sort of get even more done, because I have multiple people who are doing the various projects with me, but it also means that I don't sit and write code every day.
Okay, and then if you can help make it a little more concrete for me
Yeah.
personally, what can you give an example of like a specific type of question that you would have used data to answer when you were a geologist? And then
Ooh.
another example now that you're working in human resources at MIT. What kinds of questions are you trying to answer with data?
Yeah. So when I was a geologist, I focused specifically on groundwater, movement of water in the subsurface. So we asked a lot of questions about what direction is the water moving and how fast is the water moving. This is water that's in the ground. So it's not necessarily rivers on the surface, but you might think of it as water moving through a sandbox. And so our questions were very much aimed at how much, how fast, what quality, was it fresh or was it salty? Because a lot of questions around water are, can we drink it? Can we use it to water our fields? That sort of thing. The questions I ask now are a little bit different. Some of the questions I ask now are through surveys often, but how involved do you feel in decisions about your work? Or that's not a great example, but like, how good is your manager at encouraging teamwork? And it's certainly a little bit different type of question, and the answers are a little, I'll say it, they're a little squishier. In the physical sciences, we were measuring, this is 3.2 volts. That's that, no debate there. But in the social sciences, where I'm using data now, there's a little more wiggle room, because the way you feel about something, your perception might depend on whether you had a snack or not. So it's definitely been a challenge for me making this transition towards a little bit different data type. But that's one of the things I've really enjoyed. You asked earlier sort of what is motivation or what's one of your favorite parts. I love that there's always something new to learn. And whether it be, coding and writing some cool code snippets, or better understanding the types of data we use. So I went back, I have a lot of degrees, I've gone to a lot of school, but I decided to keep learning. And I've now been taking some classes in survey science, for example, because that's a whole nother field related to the data I use, but it's a little bit different way of thinking about it. Again, we're not measuring like 3.2. We're measuring, I feel good, I feel not good. And that's definitely been a little bit of a transition for me. But again, I've enjoyed it because there's been an opportunity to learn more.
Mm-hmm. Well, great. I also wanted to ask, and this will be for both of you, you've both talked about how you don't do this work alone, it sounds like. And that can counter a lot of images that people have about science in general, where it's very solitary, you're just sitting in front of a computer, um, and you may or may not be your own genius coming up with your own questions and answers. What is your day-to-day actually like? How much of it are you sitting in front of a computer by yourself and writing code and checking out patterns and data? And how much of it is something else, collecting data, talking with other people? Can you describe a little bit of that? So since you're unmuted, how about Emily, you go first and then Sydney.
Yeah. I spend most of my time in front of a computer now, especially because we tend to have meetings on Zoom now. But I would say about half of my day is probably having meetings with other people, talking about data. So I mentioned that my team is doing a lot of work building dashboards now. These are like reactive, basically websites where folks can go and look at their data, but start to ask some of the questions themselves. Okay, we see that everybody, this many people feel like their manager is doing a good job building teamwork. But is there a difference between, if somebody is new in their job or somebody's been around a long time? So building some functionality to allow managers to look at those questions themselves. And so It seems maybe like a fairly simple thing to just put it up there for everyone to use. But we have to have a lot of conversations about, where is this coming from? Where are we storing the data? Are we going to let people look at the individual lines of data, or are we only going to let you look at the sort of overall scores, the average scores for everybody? Are we going to let everybody look at this data? Are we only going to let managers look at this data? And so that's sort of an example of what some of those meetings are about. I then get to have meetings with my team who are building the dashboards, and those are probably some of my more fun ones because they say, Emily, I've gotten 90% of the way there, but there's this blocker and we can't figure out how to make this number show 2 decimal points instead of 3. And then we get to sit, and that's sort of the coding side where we get to talk about, okay, well, could we use this technique? Could we round it? Or, do we have to turn it into text and just delete the last character? So those are sort of the 2 different types of meetings that I have. And I enjoy having a mixture of them. I don't get a whole lot of choice in my day-to-day, but I like to make sure my weeks are sort of evenly distributed between the planning, the doing, and actually some time for me to do too, because that's what again, that's the part I really enjoy. So I really try to make sure I save a couple of hours a week to do the part that sort of makes me the most excited.
Well, great. How about Sydney? Same question to you. What's your day like?
My day is typically starts with taking the dogs out and eating something, but then it's just walking into one of the rooms of my home and popping down from the computer, and depending on whether I turn my computer off the night before or not, picking up where I left off or seeing what's new. I'd say about maybe a third of my time is meeting with people, but that also doesn't really capture the interactions that I do over instant messaging. So as I'm working on a project, if it's for a scientist, I might pop in and say, I think I'm working on this thing, but I'm missing this small little detail for this or that. Can you clarify? And get that answer fairly quickly, typically. Part of my time is also starting to get, I'm also managing like a team for a larger-ish project now. And so part of my time is taken up by writing sort of like documentation. So what's our path forward going to be like, and what are the different methods that we're going to attempt to do, and is it does this thing that we discussed in our last meeting, is that going to move forwards? Are we going to move forwards with that or not? Is it a dead end? And so there's parts like that, but I also very much still enjoy the writing of the code and creating of the tools for the eventual end users. Um, let's see. I usually uh, have a bit of time off during the middle of the day where I make sure that I block out some time so I can again take the dogs out for a walk, and it's a good time to switch tasks. So I'm most likely to uh, try and have my meetings in the morning so that anything that needs to be said or be updated happens earlier in the day so that any actions that need to be taken from those meetings happen later in the day. And I also similarly try and keep my Fridays open, but it's difficult. There's always somebody that has no other available time to do things, and that's that.
Yeah.
Yeah.
Well,
Part of what I do as well is planning workshops. So we're doing an AI machine learning workshop for scientists at Hui, so they have a better understanding of how that works. And I'm writing curriculum stuff for them. So it's not just direct project work, but it's also a portion of like outreach and education, within our community.
Well, that leads to a question that someone has posted in the chat, which is how do you handle communicating data findings to people like in the community who don't have a technical or data science background?
Mm.
How do you go about that?
Um, I mostly leave that part up to the scientists that I work with. I can kick back and say, I've enabled you. Now you go do your research. Um, so on the one hand, that's one thing. On the other hand, to like friends and family and people who are interested in what I do, I show them pictures similar to the ones that were in the presentation. I'm like, look at all these microscopic pictures. This is what I work with. Um, and that's always kind of fun and interesting. Mm, on the more technical side of things for sharing uh, materials with the community, there are websites where people can upload data sets and models and the sort of data sets that were used to train models. Those are websites like Kaggle or Hugging Face, where the the data is almost as important as the computer model from which the models were made from, because for reproducibility and also for an ethics standpoint from knowing where your data came from, it's important to be able to share and publish both of those when making AI and machine learning type things.
Okay, Emily, what are your thoughts?
So that is something that's very important to me, especially in my role, working in human resources and talking to a lot of different people. The last big project I worked on was this engagement survey. So it was a survey that we gave to all of the employees where I work. And I've spent the last 2 months or so working through the data. And it culminated in a big presentation to the whole organization about what we saw, sort of high level, where things are looking good, where we might want to focus our attention to improve things. And it's really important to me when I deliver that type of presentation that it be accessible to everybody who works here. So that includes, PhD scientists. That also includes the mechanics who make sure our equipment works, and provide electricity to all of our laboratories. And so in some ways it's a little bit like the example of building code that I talked about, but it's building it in pieces. It's starting off with the basics and sort of here is the overall, and making sure I do use a lot of diagrams and pictures, but making sure that all of the pieces are explained, that you don't assume, just because I put this up here that everybody's going to know what it is. So you will often find me talking through charts, like this is what's on the x-axis. And, when the numbers get bigger this way, that means blank. And a big part of it is also practicing and sharing it with other people to make sure, hey, does that make sense? Did you understand this? Before I go share this with 2,000 people, let's do a little test audience and make sure that these things make sense. And I think a big part of it is being open to questions and, understanding that we all come from sort of different points of view. And sometimes I get a little thrown by questions because, that people are just thinking about things in a really different way than I ever have. But, bringing in the curiosity of, okay, what's causing you to ask this question? What didn't I explain clearly? Or what did you interpret in a way that I never, thought that could be done? During graduate school, I took a class in science communication, and thinking even about some of the words that we've used here, the example is model, and we talk all the time about computer models. And I remember they did this exercise, and it was like, you say model and you think computer model, you know, I say model and I think Miss America. And it was like, oh, right. And there were just like a lot of different examples of that, of, things, words that we would throw around that seemed so obvious what this meant, and just recognizing that like it's not necessarily what everybody else thinks of.
Mhm.
So, and some of it you learn by mistake, some of it you learn again when you sit and you're like, I wonder why that person asked that question. And it's like, oh, I made this assumption that was just wrong. So,
Mhm. I want to ask this question. We only have a few minutes left. I don't see too many other questions coming in from the chat. If we want to inspire young people to go into data science, but we also hear that AI may be taking everything over, maybe doing a lot of analysis and thinking for us. What do you think about that? And how are you thinking about your own future as AI capabilities continue to grow?
a great question. And I think, again, because of communication, there will always be a job. It may change. But I feel pretty confident that we will always need somebody to tell the machines what to do and sort of come up with the why. AI is a very powerful tool. It's one that I use. And so again, like continuing to learn with it and understand how it can help me in my job. I frequently use it when I write code these days. And again, coming back to the points of like, I still need to know what to tell it to do. I still need to think about, this is the data set. What am I trying to get out of it? Because, AI and any powerful tool can give you averages and point to the means and, give you clusters of data. But if it's not meaningful, then, why are we doing it? I think about survey data, and like we could put any number of factors into it, like shoe size. We could look at scores by shoe size, but like, is that really doing anything for us? No. Because there's no way for us to respond like, oh, people with small shoes, like that's not something for us to do. And so, yeah, it definitely is changing the space. When it first came out, or when I first started interacting with AI a couple of years ago, I was like, I'll never use that to write code. Like that's I'm so proud of my code writing abilities. But realizing like I can write so much more code, and and more effective code if I use this as a tool. So.
Can I give Sydney a chance? We're almost at the end. Sydney, if you can answer really quickly, then we'll wrap.
Sure. I use it too, but I never use it wholesale. I think going back to the question of the knowing what to ask is really important. And so I will use it to say, I I want to know what sort of technologies that the rest of the community has already built to address the similar kind of problem. And so that might be I'm looking for a particular way to, I need to know what kind of software exists to write a website, and it might list out a whole bunch of them, many of which I might not have heard before. So I tend to use it as an exploratory tool when I come across a new kind of problem or challenge that I don't immediately know how to address. But because sometimes they still hallucinate, I go and follow that up and read the actual documentation for whatever thing it might suggest. And
Yeah.
so I'll never use it wholesale, but for bits and parts of a software where it's either routine or I know what to expect from it, I might be like, I don't want to physically type all of that out, and I might have it spit something out. But the more guardrails and the more precise you are with the language, the more useful and powerful a tool it is. And so that's why I think It's not going to replace expertise. It's kind of like having a junior assistant who can bang something out for you. And the more precise you are with the language, the better they're going to enable you. It's just some other tool. Yeah.
Well, great. Thank you. We're now at 5 p.m., so we are officially at the end of our time here. I want to give a huge thanks to both of you, Emily and Sydney, for speaking with us today, primarily with me. But I love talking with you, sharing your insights, your interests. I want to thank everyone who attended for being here and showing your interest in this webinar series and in our speakers. We're going to have more of these the next academic year. We would really love your feedback on today's session. Jen will be sharing a link for you to take a very brief anonymous 3-question survey, which will then take you to another link.
Data, you're making data. Sorry.
Yes, we are. Exactly. I'm a researcher. I love collecting data. And then that will bring you to another link if you want to sign up to receive a certificate of attendance. Come to our website if you're a teacher and you'd like to explore any of our teacher PD workshops or classroom curriculum materials or our career hub of resources for students. And we aim to have this recording or clips of it posted on our website so that you can use it in the future. Thank you, everybody,
you.
so much for attending. Did I cut somebody off? Someone want to say?
No, I just wanted to say thank you. Thank you for mediating. Thank you
Well,
for bringing us all together.
Thank you so much, and I hope everyone has a great rest of your day. Bye. Thank you.